Thank you for joining another math lesson hosted by Book&Table. I am your math tutor, Maurice Wright, and in this chapter we are going to review the basic operations to radicals. We'll review how to add two radicals, how to subtract radicals, how to divide a radical by a radical, how to multiply two radicals, and then we'll wrap things up by discussing how to simplify radical expressions. Should you have any follow-up questions, feel free to leave them in the comments section. Or you can connect with a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. So let's first discuss squares and square roots. The square of a number, x, is that number times itself. A perfect square is a result of squaring a whole number. So let's first discuss this first statement. The square of x is equal to x times itself, x times x, which gives us a perfect square, which would be x squared. If we replace x with a whole number, in this case 4, the square of 4 is 4 times itself, 4 times 4, which is 4 squared, which is equal to 16. Now, radicals help us go from this value to figuring out what numbers can be multiplied to get to 16. And we have positive 4, but we also have negative 4. The square of negative 4 is negative 4 times negative 4, which is negative 4 squared. A negative times a negative is positive. So again, perfect squares are the results of positive values being multiplied by each other. 1 times 1 gives us positive 1. 2 times 2 gives us 4. 3 times 3 would give us 9, so on and so forth. But negative 3 times negative 3 also gives us 9. Negative 2 times negative 2 also gives us 4. And negative 1 times negative 1 also gives us 1. So when we say the square root of 16, it would be positive 4 or negative 4. The square root of a number is the number that is multiplied by itself to get the original number. So the square root of 16 is equal to the number you'd have to multiply by itself to get to 16, which would be 4 times 4, or negative 4 times negative 4. So these would be the square roots of 16. Now throughout this video, when we refer to the square root of a positive radicand, we'll just be discussing the positive square root, just to keep things simple. Let's discuss the radical sign, this right here. It is also called the radical symbol or the root symbol, and it indicates the square root or a higher order root of a number. So when there's no number place here, it is implied that the root is 2. When we have a radical sign in our expression, it is called radical form. Radical signs are used as a form of notation to represent fractional exponents. So what does that mean? When our term is in radical form, we have a to the power of m to the root of n. Now, in exponential form, if this exponent were a fraction, it would be this, a to the power of m divided by n. So these two are equivalent to each other. This is the radical form of the term, and this is the exponential form of the term, a to the m over n. Now, m is our power, and n is called the index. A, the number inside, or the base, is called the radicand. Now when we have a term in exponential form or radical form, remember the denominator here, or the index, must be equal to or greater than 1. It cannot be 0 or negative. And a must be a real number. So keep that in mind. When the index is equal to 2, it is usually not included in the radical form notation of a term. So if we have 4 to 3 halves, this would be equal to 4 cubed, 4 to a power of 3. to the root of 2. This is called the square root. So these two terms would be equivalent. It'd be the same as not writing the 2. So when you are given this as a term in exponential form, it is 4 to the 3 divided by 2. When this is not shown, it is 2. And remember to go back to exponential form to help you simplify these terms. This will come up later in the video when we are simplifying the expressions. So keep this in mind. The square root of a term A is equal to the square root of a term A. The 2 is written or not. These two are equivalent. Now let's discuss adding radicals. A radical can only be added to another radical if the radicand of each radical is the same. If so, combine the terms into a single term by adding the coefficients. Now the radicand is the term or number inside or under our radical sign. So these must be exactly the same in order to combine these two terms into one. And we do so, if they're being added, by adding their coefficients a and b. So a radical x plus b radical x would be equal to the sum of a plus b radical x. So instead of writing our radical twice, we can write it once. For example, 4 radical 2 plus 7 radical 2 is equal to 4 plus 7 radical 2, which would be 11 radical 2. And these are considered like terms because the radicand is the same. Okay, so when I say combine like terms, I mean the terms that have the same radicand. This would be an example of an expression that cannot be simplified any further. 4 radical 2 plus 7 radical 3 cannot combine because the 2 is not equal to 3. So this would be the furthest it can be simplified. 4 radical 2 plus 7 radical 3 is equal to 4 radical 2 plus 7 radical 3. The same if the radicands were variables. X is not equal to y. They represent different values. So these radical terms could not be combined either. Let's do some practice questions. Find the sum. Question number 1. Negative 7 radical 3 plus 10 radical 3. Question number 2. 2 radical 4 plus radical 4 plus d radical 4. And question number 3. 3 radical x plus 2 radical z plus 2 radical x. Pause the video, solve these questions, and then press play when you are ready to begin. Step 1, group together the like terms. So in this particular question, we're only provided 2 terms, and they are like terms already. So this was already done for us. Step 2, combine the like terms by adding the coefficients. So we combine these two terms by adding negative 7 and positive 10, which would be positive 3. And we keep our original radicand, 3. So the answer to question number 1 is 3 radical 3. Question number 2, step 1, group together the like terms. In this question, again, each of the radicands are the same, positive 4, so we've already grouped them together. Step 2, combine the like terms by adding the coefficients. The coefficient to our first term is positive 2. The coefficient to our second term is 1. If nothing is shown, it's equivalent to 1, positive 1. 1 times anything would just be itself. So radical 4 is the same as 1 times radical 4. So that's why the coefficient is 1. And the third term, our coefficient is positive d. So we can combine positive 2 and positive 1 to give us 3 plus d times radical 4. So this would be the answer to question number 2. Question number 3, step 1, group together the like terms. So in this expression, 2 of our terms are like terms. Here we have x and here we have x. So we want these beside each other. And then step 2, combine the like terms by adding the coefficients. So 3 plus 2 would give us 5 radical x, plus our third term, 2 radical z. So this would be the answer to question number 3. So as you see, when you are adding radicals, you will not always wind up with just one term as your answer. So do not try to force that whenever you are simplifying terms, as you will see later on in this chapter. Now let's move on to discussing how we go about subtracting radicals. Similar to addition, a radical can only be subtracted from another radical if the radicand of each radical is the same. If so, combine the terms into a single term by finding the difference in the coefficients. So instead of addition, it's subtraction. Everything else remains the same as far as the process of simplifying these. So let's say we had a radical x minus b radical x. They are like terms, or they have the same radicand. So we can subtract the coefficients. So we have a minus b. So this would simplify to the difference of the coefficients times the radical. If we replace these with real numbers, 8 radical x minus 3 radical x would be equal to 8 minus 3 radical x, which would be 5 radical x. Like addition, you cannot combine terms that do not have the same radicand. So 8 radical x cannot combine with negative 3 radical y because the x and the y are not equal to each other. So this would be the furthest you'd be able to simplify this expression. Same if the radicands were real numbers. 8 radical 2 minus 3 radical 5 cannot be simplified any further because the 2 is not equal to 5. Let's have you do a few practice questions. Find the difference. Question number 1, 10 radical 3 minus 7 radical 3. Question number 2, 6 radical a minus 7 radical b minus 4 radical a is equal to what? And question number 3, 12 radical 6x plus 7 radical g minus 9 radical 6x minus 3 radical g. Pause the video, answer these questions, and then press play when you are ready to begin. So finding the difference and adding the radicands are the same, except our signs are different. That's the only difference between addition and subtraction. Step 1, group together the like terms. So both of our terms already have the same radicand, which makes them like terms. So step 2, combine the like terms by adding the coefficients. So 10 plus negative 7 is equivalent to finding the difference, which would be 10 minus 7, which is equal to 3 radical 3. So the answer to question number 1 is 3 radical 3. Question number 2, step 1, group together the like terms. So 6 radical a and negative 4 radical a have the same radicand, so we put those beside each other. So that's step 2. When we combine the like terms by adding the coefficients, we see that 6 minus 4 is equal to 2 with our radical a, so 2 radical a. And then that just leaves our third term with a different radicand b, negative 7 radical b. So the final answer to question number 2 is 2 radical a minus 7 radical b. Question number 3. Step 1, group together the like terms. So our first term, 12 radical 6x. And our third term, negative 9 radical 6x. Those have the same radicand, so we group those together. And then we have g as another radicand for two of our terms. So we group those together, positive 7 and negative 3. And then step 2, we combine the like terms by adding the coefficients. So 12 minus 9 would give us 3 radical 6x. And 7 minus 3 would be 4 radical g. So the final answer to question number 3 is 3 radical 6x plus 4 radical g. Now let's discuss how we go about dividing radicals. Any radical term can be divided by another radical term, and the terms do not need to have the same radicands. So a radical x divided by b radical y is equal to a over b times the square root of x over y. So what this shows is, in order to divide radicals, you divide the coefficient in the numerator by the coefficient in the denominator, and you divide the radicand in the numerator by the radicand in the denominator. You do this for any radical terms, regardless of what the radicands for each term are. So let's take a look at this example. 6 radical 10 divided by 2 radical 5. Step 1, you divide the coefficient in the numerator, which would be 6, by the coefficient in the denominator, which would be 2. 6 divided by 2 gives us 3. Step 2, divide the radicand in the numerator, 10, by the radicand in the denominator, 5, giving us, and we keep the radical, the square root of 10 divided by 5, which would be 2. So the answer to 6 radical 10 divided by 2 radical 5 is 3 radical 2. So when you want to divide radicals, again, divide the coefficients and then divide the radicands. Let's have you do a few practice questions. Find the quotient. 14 radical 20 divided by 7 radical 4. Question 2, 8 radical 4 divided by 2 radical 16. And question number 3, 3 radical 12x to the 4th divided by 6 radical 3x squared. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, divide the coefficient in the numerator, 14, by the coefficient in the denominator, 7. 14 divided by 7 is 2. Then we go to our radical terms. Step 2, divide the radicand in the numerator, 20, by the radicand in the denominator, which should be positive 4. The square root of 20 divided by 4 is equivalent to the square root of 5. So the answer to question number 1 is 2 radical 5. Question number 2, step 1, divide the coefficient in the numerator, 8, by the coefficient in the denominator, 2. 8 divided by 2 gives us 4. Step 2, divide the radicand in the numerator, 4, by the radicand in the denominator, 16. 4 over 16. If you divide them both by 4, you simplify it to 1/4. Now the square root of 1 can be simplified to 1, and the square root of 4 can be simplified to 2. So 1 over 2 is equivalent to 1/2. 4 times 1/2 is equal to 2. So 8 radical 4 divided by 2 radical 16 is equal to 2. Question number 3, step 1, divide the coefficient in the numerator, 3, by the coefficient in the denominator, 6. 3 over 6 is equal to 1/2, or 0.5 in decimal form. Step 2, divide the radicand in the numerator, 12x to the 4th, by the radicand in the denominator, 3x squared. 12 divided by 3 is equal to 4. When you are dividing variables with exponents, you subtract the exponent in the denominator from the exponent in the numerator. So 4 minus 2 gives you 2. Now the square root of 4 is equal to 2, and the square root of any term squared is just the root x. So the square root of 4x squared can be simplified to 2x. 2 times 1/2 is 1, which means this answer simplifies to just x. So 3 radical 12x to the 4th divided by 6 radical 3x squared is equal to x. Let's now discuss how we go about multiplying radicals. Any term can be multiplied by another term, and the terms do not need to have the same radicands. Now, what we do is we multiply the coefficients of each radical term. A times b gives us a times b, and multiply the radicands of each radical term. X times y gives us x times y. So in division, it does not matter what our coefficients or our radicands are. You can divide any two radical terms. And in multiplication, the same thing. You multiply the coefficients regardless of what they are. You multiply the radicands regardless of what they are. So let's say you were given 7 radical 2 times 3 radical 5. Step 1, you multiply the coefficients of each term. 7 times 3 in this case. And then step 2, you multiply the radicands of each term, 2 and 5. 7 times 3 is 21. 2 times 5 is 10, giving you a final answer of 21 radical 10, since this cannot be simplified any further. Let's have you do a few practice questions. Find the product. Question number 1, -3 radical 6 times a radical 2. Question number 2, x squared radical 7a times x radical 7a cubed. And question number 3, 4 radical 2 times 5 radical 3 times 2 radical 4. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, multiply the coefficients of each term, -3 and a, giving us -3a. Step 2, multiply the radicands of each term, 6 and 2, giving us radical 6 times 2, which is radical 12. So the answer to question number 1 is -6a radical 12. If you simplified it further, you would have gotten -12a radical 3. I'm going to skip the steps on how to simplify this for now. I just wanted you to know if you got it correct, if you got down to this answer. I'm going to show you how to simplify the terms in just a moment, so we'll save that. Question number 2, step 1, multiply the coefficients of each term. The first coefficient is x squared, the second coefficient is x. When you're multiplying variables with exponents, you add the exponents. 2 plus an exponent of 1. When it's not shown, it's 1. 2 plus 1 gives us 3. So we get x cubed. Step 2, multiply the radicands of each term. 7a and 7a cubed. The exponent 1 plus 3 gives us 4. 7 times 7 is 49. Now we simplify this further because 49 has a perfect square root. And we can simplify a to the 4th. So we would get x cubed times the square root of 49, which is 7, and the square root of a to the 4th, which is 2. So our final answer would be x cubed times 7a squared, which is equivalent to 7a squared times x cubed. It's just conventional to have our real number in front and then I just put them in alphabetical order. But since it's multiplication, you can organize these in any way, and it's the same value. Let's take a look at question number 3. Step 1, multiply the coefficients of each term. The first coefficient is 4, the second coefficient is 5, and the third coefficient is 2. 4 times 5 is 20. 20 times 2 is 40. Step 2, multiply the radicands of each term. Radical 2, radical 3, radical 4. 2 times 3 is 6. 6 times 4 is 24. So the final answer is 40 radical 24. You could have simplified this further to 80 radical 6. Now, let's dive further into the details of how we go about going from a term like 40 radical 24 to a simpler term, 80 radical 6. So we're going to discuss simplifying radicals. Now, this plays off of the concept that we were just discussing, multiplying radical terms, in which we said any two terms can be multiplied. So radical A can be multiplied times radical B to give us A times B, or radical A times B. Simplifying radicals is essentially going the opposite direction, taking a radical term and breaking it up into two separate radicals. So the first radical times the second radical gives us one radical with the radicands multiplied, or we can break it up into two radical terms being multiplied by each other. All right, so since any radical terms can be multiplied, then any radical can be broken up into a product of its factors. So let's take a look at this with actual values. Let's say we had the square root of 8, or radical 8, and we wanted to simplify it. We would break it up into a product of radical 4 times radical 2, and we choose these two factors of 8 because 4 is a perfect square. We can find the square root of 4, which should be 2, allowing us to simplify this term, radical 8, into 2 times radical 2. Now, why do we want to go through the trouble of simplifying a radical term? It's because in some examples, we'll have multiple radical terms, and as it first appears, an expression like this, radical 8 plus 3 times radical 2 are not like terms. But when we simplify radical 8 and we get 2 radical 2, now we have two like terms that can be combined further by adding their coefficients. So simplifying radicals is a method that is going to help us consolidate radical terms. Now, in the previous example that we saw a few moments ago, we had 40 radical 24. So if we wanted to simplify a radical, step 1 is to remove a factor that is a perfect square. In this case, if we're considering the factors of 24, we would have 1 times 24, which would not help us. We would have 2 times 12, but 12 is not a perfect square. Then we get 4 times 6. And we choose these factors because 4 is a perfect square. The square root of 4 is 2. So this allows us to go from 40 times radical 4 times radical 6. We evaluate radical 4, which is equal to 2. And now we have 40 times 2, which gives us 80. And that is how we wound up with 80 radical 6. Okay, so when you are simplifying radicals, again, examine the radicand. Consider the different factors that will allow you to get to the radicand, and then choose the pair of factors, one of which is a perfect square, so that you can simplify this radical, and then change your coefficient along with the new radicand. Let's have you do a few practice questions. Simplify question number 1, the square root of 48. Question number 2, the square root of 50. Question number 3, the square root of 60. And question number 4, the square root of 72. Pause the video, answer these questions, and then press play when you are ready to begin. Step 1, remove a factor that is a perfect square. In this case, that would be 16. 16 times 3 equals 48. So we wind up with radical 16 times radical 3. Step 2, simplify the radical. So the square root of 16 is equivalent to 4. So the answer to question number 1 is 4 radical 3. Question number 2, the square root of 50. Step 1, remove a factor that is a perfect square. So if we're considering the factors of 50, 2 times 25 equals 50. And we like these factors because 25 is a perfect square. The square root of 25 is 5. So the answer to question number 2 is 5 radical 2. Question number 3, the square root of 60. Step 1, remove a factor that is a perfect square. So 2 factors of 60 are 4 times 15. 4 is a perfect square as we know, so we use that, giving us 2 radical 15. And then lastly, question number 4. Step 1, remove a factor from 72 that is a perfect square. That would be 36. 36 times 2 equals 72. Step 2, simplify the radical. The square root of 36 is 6, giving us the answer 6 radical 2 for question number 4. So this is how you would simplify a radical with just numerical values as the radicand. But there will be some examples that you will be provided in which the radicand has a variable included as well. So let's take a look at radical 4x squared. This is the same as radical 4, the first term, times radical x squared. The square root of 4 is equal to 2. The square root of x squared is equal to x. So the square root of 4x squared is equal to 2x. Now, we can also wind up with the negative radicand. If the radicand is negative and the index here is odd, then the final term will be both real and negative. If the radicand is negative and the index is even, then the final term will be imaginary. So we'll take a look at that in a second. So let's look at this first concept. The index is odd. So the cube root of negative 64 is equal to negative 4 times negative 4 times negative 4, which would give us negative 64. So what times itself 3 times would give us negative 64? That number would be negative 4. So that's a real number, and it's negative because our radicand was negative, but our index was odd. But if our index is even, it's not real, because there's no number times itself that will give us a negative product. Positive 8 times positive 8 is positive 64. So the square root of 8 times 8 is not equal to the square root of negative 64. Nor is the square root of negative 8 times negative 8, because that would be positive 64 as well. So instead, what we have to do is we have to extract that negative 1 times 64. So this would be the same as the square root of negative 1 times the square root of 64. The square root of 64 is 8. And the square root of negative 1 is called the imaginary term. So the square root of negative 64 is 8i. Right? This is imaginary. So this is how we deal with negative radical terms. We extract the negative value, and the square root of negative 1 is equivalent to I. The square root of negative 1 is equal to the term I, which is our imaginary unit. Now this leads us to complex numbers. A complex number is a combination of a real number and an imaginary number. Either part can have a value of 0, so all real and all imaginary numbers are complex numbers as well. So 7 plus 4i is an example of a complex number in its most simplified term. These two cannot be combined because this is real and this is imaginary. 6 plus 0i is equivalent to 6. 0 times anything is 0. But the term 6 is equivalent to 0 imaginary values. Right, so this is more semantics than anything, but it's just another example of what our final answers will look like when we start simplifying radical terms that have negative radicands. Imaginary values come into play. Another example, 0 plus 7i is equal to 7i. Now, when we wind up with an answer like 11 minus 9i squared minus 8i, we replace I squared with negative 1. 11 minus 9 times negative 1 is negative 9 times negative 1, which is positive 9. Positive 9 plus 11 is 20. So this would simplify to the complex number 20 minus 8i. Now let's dive into this concept further of simplifying imaginary units. Imaginary numbers with an exponent larger than 1 can be reduced by replacing I to the power of 2 with negative 1 and I to the power of 4 with positive 1. So we've established that we're using I, the imaginary unit, to help us deal with negative radicands. So I is equal to the square root of negative 1. I squared, any square root times itself, is simply the radicand, negative 1. Do not confuse this with this. The square root of negative 1 times the square root of negative 1. Negative 1 times negative 1 would be positive 1. So the square root of positive 1 would be 1. So when you're dealing with complex numbers and imaginary units, some of our conventional rules do break. So I just want to point out, when you are dealing with I squared, do not replace it with positive 1. We are dealing with this. The square root of negative 1 squared. It means we simply remove the radical, leaving us with negative 1, not positive 1. I cubed is equal to I squared times I. I squared is negative 1. Negative 1 times I is negative I. So I cubed can be simplified to negative I. And I to the fourth is equal to I squared times I squared, which is negative 1 times negative 1, which is equal to positive 1. All right, so that is how we simplify larger imaginary units. Let's have you do a few practice questions. Simplify. Question number 1, the square root of negative 36x to the 6th. Question number 2, the square root of negative 25x to the 8th. And question number 3, 3i radical negative 5 times 2 radical 6 minus I radical negative 7. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, remove the imaginary unit from the radical. So we have negative 1 here, so we take that out. So now we have a positive radicand. Step 2, we simplify the radical. So we replace the square root of negative 1 with I. So we have I radical 36x to the 6th. So now we want to simplify the radical term further. Step 3, remove a factor from the radicand that is a perfect square. So that would be 36. So we take that out. Radical 36x to the 6th is equal to this factor times this factor. So that's how we get radical 36 times radical x to the 6th. Now we simplify these radicals. The square root of 36 is 6. So we wind up with 6 times I, which is 6i. And remember, the square root is equivalent to having an index of 2. So the square root of x to the 6th is equal to x to the 6th to a power of 1/2. So we wind up with 6 times 1/2, which is 3, leaving us with a final answer of 6i x cubed. Question number 2. Step 1, remove the imaginary unit from the radical. So we take out -1, and then we simplify the radical to I, leaving us with I radical 25 x to the 8th. And now we simplify this further. So step 3, remove a factor from the radicand that is a perfect square. That would be 25. The square root of 25 is 5, leaving us with 5 times I, which is 5I. This index is 2, but it's not shown, it's 2. So x to the 8th to a power of 1/2. Power of 1/2 is the square root. 8 times 1/2 is 4, leaving us with the final answer of 5I x to the 4th for question number 2. Question number 3, we had to distribute our term on the outside to each term on the inside of the parentheses. Step 1, distribute the term on the outside to each term on the inside of the parentheses. So we multiply our coefficient, 3i, times our first coefficient 2, which gives us 6i. We then multiply the radicands of those terms. -5 times 6 gives us -30. And then we repeat that process with this term and the second term. So 3i times -i gives us -3i squared. And then we multiply their radicands. -5 times -7 gives us +35. So after step 1, we have 6i radical -30 minus 3i squared radical 35. And now we want to simplify these terms even further. So step 2, remove the imaginary unit from the radical. So we take this -1 out and we replace it with I. So 6i times I gives us 6i squared. And over here we have -3i squared still. And now we can replace each I squared with -1. So 6 times -1 is -6. -3 times -1 is +3. And since we cannot remove a perfect square from either of these radicands, this is the most simplified version of our expression. -6 radical 30 plus 3 radical 35. Now let's discuss another situation in which you will be multiplying binomials, and that will require you to simplify the product that you get. A binomial is a term that has two parts. So when you're multiplying two binomials, we want to utilize a method known as the FOIL method. The FOIL method is a technique used to remember the steps required to multiply two binomials. So FOIL stands for first, outside, inside, and last. F-O-I-L, FOIL. So when you hear that, this can help direct you to which terms you should be multiplying. So you want to multiply this first term times each term inside this set of parentheses here. And then you want to multiply the second term by each of these terms as well. So you multiply the first terms first, the first term in the first set of parentheses times the first term in the second set of parentheses. A times C would give you AC. O stands for outside. A times D will give you AD. Then I stands for inside. So we are now moving to the second term in our first binomial, and we're multiplying it times the first term in the second binomial. We're multiplying the inside terms. And then lastly, you multiply B times the second term in the second set of parentheses, D. B times D will give you BD. So again, FOIL stands for first. Multiply the first term in each set of parentheses, A times C. O is outside. A times D gives you AD. I is for inside. B times C gives you BC. And L stands for last, the last term in each binomial. B times D gives you BD. Let's take a look at an example of multiplying two binomial terms. Evaluate and simplify 4 radical 5 plus 2 radical 3 times 6 radical 5 minus 7 radical 3. So step 1, use the FOIL method to expand the expression. So F stands for first, so we're going to multiply the first term in the first binomial times the first term in the second binomial. When you're multiplying radicals, you multiply the coefficients times each other. 4 times 6 gives you 24. You then multiply the radicals. Radical 5 times radical 5 will give you radical 25, or the square root of 25, which is equal to 5. 24 times 5 gives you 120. You then go to the outside terms. 4 times negative 7 gives you a coefficient of negative 28. And radical 5 times radical 3 will give you radical 15. You then multiply the inside terms. 2 times 6 will give you a coefficient of 12. And radical 3 times radical 5 gives you radical 15. Then lastly, the last terms. 2 times negative 7 will give you a coefficient of negative 14. And radical 3 times radical 3 gives you 3. Negative 14 times 3 will give you negative 42. So once you expand the expression by using the FOIL method, you have 120 minus 28 radical 15 plus 12 radical 15 minus 42. So the next step is to combine the like terms. So you'll do 120 minus 42. And then you combine the radicals that have the same radicand. So these are both radical 15. So you can combine the coefficients, negative 28 and positive 12, to give you negative 16 radical 15. 120 minus 42 is 78. So 4 radical 5 plus 2 radical 3 times 6 radical 5 minus 7 radical 3 is equal to 78 minus 16 radical 15. So that is how you would use the FOIL method. Let's have you try a few practice questions. Evaluate and simplify. Question number 1. 3 radical 7 minus 4 radical 6 times 9 radical 6 minus 2 radical 7. Question number 2. Negative 5 radical 2 plus 10 radical 3 times 8 radical 2 minus 7 radical 3. Question number 3. 3i radical 2 minus 5 radical negative 8 times negative 4 radical negative 8 plus 6i radical 2. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. Step 1. Use the FOIL method to expand the expression. So the F in FOIL stands for first, which lets you know you want to multiply the first term in the first binomial times the first term in the second binomial. When we do so, we want to multiply our coefficients first, 3 and 9. 3 times 9 will give you 27. And then you multiply your radicands. Radical 7 times radical 6 will give you radical 7 times 6, which is radical 42. You then go to the outside terms. The O in FOIL stands for outside. So the first and the last term. 3 times negative 2 gives you a coefficient of negative 6. Radical 7 times radical 7 gives you 7. Negative 6 times 7 is negative 42. You then move to the inside terms. Negative 4 times 9 gives you a coefficient of negative 36. Radical 6 times radical 6 gives you 6. Negative 36 times 6 is negative 216. And then you multiply the last terms in each binomial. Negative 4 times negative 2 gives you a coefficient of positive 8. Radical 6 times radical 7 gives you radical 42. So now that we've expanded the expression, the next step is to combine the like terms. So you want to combine the radicals that have the same radicand. So these both have a radicand of 42, so we can combine their coefficients, positive 8 and positive 27, to get positive 35, radical 42. And negative 42 minus 216 gives you negative 258. So the final answer is negative 258 plus 35, radical 42. Question number 2. Step 1, use the FOIL method to expand the expression. The F in FOIL stands for first, so you multiply the first term in the first binomial times the first term in the second binomial. When you do so, you multiply the coefficients, so that gives you negative 5 times 8, which gives you negative 40. Then you multiply the radical terms. Radical 2 times radical 2 gives you the square root of 4, which is 2. Negative 40 times 2 is negative 80. You then multiply the outside terms. Negative 5 times negative 7 will give you a coefficient of positive 35. Then you multiply the radical terms. Radical 2 times radical 3 gives you the square root of 2 times 3, which is radical 6. Now that you've multiplied the first term by both of these terms, you then move on to the second term, and when you're going to multiply this times each of these. So the next step is to multiply the inside terms. Positive 10 times positive 8 gives you a coefficient of positive 80. Multiplying the radicals gives you radical 3 times radical 2, which gives you the square root of 6. And then you multiply the last term in each binomial. Positive 10 times negative 7 gives us a coefficient of negative 70. And then when we multiply the radicals, we get radical 3 times radical 3, which gives you the square root of 9, which is 3. Negative 70 times 3 gives you negative 210. And now that we've expanded the expression with the FOIL method, we can simplify this by combining the like terms. When you do so, negative 80 minus 210 will give you negative 290. And positive 35 radical 6 plus 80 radical 6 will give you positive 115 radical 6. So the final answer is negative 290 plus 115 radical 6. And now question number 3. Step 1, use the FOIL method to expand the expression. F in FOIL is for first, so we multiply the first term in this binomial times the first term in this binomial. 3i times negative 4 will give us a coefficient of negative 12i. Radical 2 times radical negative 8 will give us radical negative 16. We then move on to O, outside. So we multiply 3i times positive 6i. 3 times 6 is 18. I times I is I squared. And then you multiply the radicals. Radical 2 times radical 2 gives you the square root of 4, which is 2. 18 times 2 is 36. Now we move to the second term, -5 radical -8. And you're going to multiply this times each term in this binomial. So I in FOIL stands for inside. Multiply this term times this term. -5 times -4 gives you a coefficient of positive 20. Radical -8 times radical -8 gives you the square root of positive 64. The square root of 64 is 8. 20 times 8 is 160. And then L in FOIL is for last. So you multiply the last term in each of the binomials. -5 times positive 6i gives us a coefficient of -30i. And radical -8 times radical 2 gives us the square root of -16. And now that we've expanded the expression using the FOIL method, we need to simplify this expression further. So we first want to get rid of the negatives in our radicals. We'll do so by removing the square root of -1, the imaginary term. When we do so, -12i times radical -16. We want to simplify this radical. We can break it up into its factors. -1 times positive 16 gives us -16. So if you were to multiply these two radicals, you would get this one. Thus, you can break this radical up into these two radicals. By doing so, the square root of -1 is I. So we get I times I gives us I squared. So we get -12i squared times the square root of 16. The square root of 16 is 4. 4 times -12 is -48. So this becomes -48i squared. We bring 36i squared down. We bring 160 down. And we remove the imaginary unit from this negative radicand as well. -16 is broken up into -1 times 16. The square root of -1 is I. So I times I will give us I squared. The square root of 16 is 4. -30 times 4 is -120. So once we remove the imaginary unit from each negative radicand, we wind up with -48i squared plus 36i squared plus 160 minus 120i squared. So now we replace each i squared with -1. -48 times -1 is positive 48. 36 times -1 is -36. And -120 times -1 is positive 120. 48 minus 36 plus 160 plus 120 equals 292. So that is how you would multiply two binomials and simplify using the FOIL method. Let's now discuss how to rationalize a denominator. To do so, we must first discuss irrational numbers. A rational number is one that can be expressed as a fraction, and an irrational number is a number that cannot be expressed as a fraction. So for example, the number 1.5 can be expressed as a fraction as 3/2. 2 goes into 3 once, and then we have 1 left over. That's the half. So 1.5 is equal to 3/2. So because 1.5 can be expressed as a fraction, we know that it is a rational number. Another example, whole numbers. 2 is equivalent to the fraction 2/1. So because whole numbers can be expressed as a fraction we know that they are rational as well. But a number like the square root of 2 has a never-ending decimal. And since it has a decimal that never ends, we know that it cannot have a number that can be converted into a fraction, since this decimal just goes on and on and on and on. So because this number cannot ever be written as a numerator, since it never ends, it is irrational. Another example, the square root of 5 is equal to 2.36067, and the decimal continues without repeating. So since this decimal goes on and on and on, there's no way to represent this number as a fraction. So we know that it is irrational. Now, we do not want irrational terms in our denominators. So sometimes you may be asked to give your answer in rational form, or you may be asked to rationalize the denominator. This is what your instructor is referring to. For a fraction to be in simplest form, it should not have an irrational number in the denominator. Rationalizing the denominator is the process of moving the radical from the denominator to the numerator by multiplying both the numerator and the denominator by the same radical. Now, you want the numerator and the denominator to be multiplied by the same radical because any number divided by itself is equal to 1, and any number times 1 is itself. So 1 over radical 2 is equal to radical 2 over 2. We are just changing the way that we represent this value by multiplying it times a fraction that is equal to 1. Anything divided by itself is 1. And anything times 1 is itself. 2 times 1 is equal to 2. 3 times 1 is equal to 3. 4 times 1 is equal to 4, and so on. So by multiplying this fraction times 1, we are able to move the radical from the denominator to the numerator, and thus we rationalize the denominator. We go from an irrational denominator to a rational one. Another example, let's say you wanted to rationalize 2 over radical 5. You multiply the numerator and the denominator by radical 5. 2 times radical 5 is 2 radical 5. Radical 5 times radical 5 gives you 5. And thus, you have rationalized the denominator by going from radical 5 to positive 5. Now, let's look at another example. Let's say you were asked to rationalize and simplify 7 over radical 7. Step 1, you multiply the numerator by the same radical that is in the denominator, so that's radical 7, or the square root of 7. And then step 2, multiply the denominator by the square root of 7 as well. When you do so, you get 7 times radical 7, which is 7 radical 7. Radical 7 times radical 7 is 7. And now step 3, simplify the fraction. This coefficient is divided by the denominator. And since 7 can be divided by 7 to give us 1, the 7's cancel each other out, giving us 1 times radical 7, which is just radical 7. Okay, so to rationalize the denominator, multiply the numerator and the denominator by the radical term that is in the existing denominator. Any radical times itself will remove the square root sign, allowing you to rationalize the denominator. Let's have you try a few practice questions. Rationalize and simplify. Question number 1, 8 divided by the square root of 10. Question number 2, 3 divided by the square root of 12. And question number 3, 4 plus the square root of 2 divided by the square root of 8. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. Step 1. Multiply the numerator 8 by the square root of 10. Since we are trying to rationalize the denominator, we want to multiply this fraction by this radical, the square root of 10. So step 1, multiply the numerator by the square root of 10. And step 2, multiply the denominator by the square root of 10. When you do so, you'll get 8 times the square root of 10, which is 8 radical 10 in the numerator. The square root of 10 times the square root of 10 equals 10 in the denominator. And now you have a coefficient and a denominator that can both be simplified by removing 2 from each one. So step 3, we want to simplify the fraction by dividing this 8 by 2 and this 10 by 2. And that gives us 4 radical 10 in the numerator divided by 5 in the denominator. So when you rationalize 8 over the square root of 10, you get 4 times the square root of 10 over 5. Question number 2. You were given 3 divided by the square root of 12. So we want to multiply the numerator and the denominator by the square root of 12. So step 1, multiply the numerator by the square root of 12. And step 2, multiply the denominator by the square root of 12. 3 times radical 12 gives you 3 radical 12 in the numerator. The square root of 12 times the square root of 12 gives you 12 in the denominator. And now we have a coefficient and a denominator that can both be simplified by dividing each one by 3. When we do so, 3 divided by 3 is 1. So 1 times the square root of 12 gives you just the square root of 12 in the numerator. And then 12 divided by 3 gives you 4 in the denominator. So when you rationalize and simplify 3 divided by the square root of 12, you get a final answer of the square root of 12 divided by 4. And question number 3. This one, we had a binomial in our numerator, but that does not change the fact that rationalizing means that we want to get rid of this square root of 8. So you're still going to multiply the numerator and the denominator by the square root of 8. So when you do so, step 1, multiply the numerator by the square root of 8. So 4 times the square root of 8 gives you 4 radical 8. Positive radical 2 times radical 8. 2 times 8 gives you radical 16. And then in our denominator, the square root of 8 times the square root of 8 is 8. So once we multiply the numerator and the denominator by the square root of 8, we get 4 radical 8 plus radical 16 over 8. Square root of 16 is equal to 4. And now we're left with 4 radical 8 plus 4 over 8. And now step 3, we want to simplify the fraction. Since it's not just this radical term over the denominator, we have to also take into account this term. We can only simplify the fraction if this coefficient, this integer, and the denominator can all be divided by the same number. And in this case, they can. They're all divisible by 4. 4 divided by 4 is 1. So you get 1 radical 8, which is just radical 8. 4 divided by 4 is 1. And 8 divided by 4 is 2. So the final answer is radical 8 plus 1 divided by 2. If you broke this up into two fractions, the square root of 8 over 2 plus 1 over 2, that is equivalent to this fraction as well. So that is how you would rationalize the denominator of a fraction if the denominator had just one term. But let's wrap things up by discussing how to rationalize a denominator that has two terms, an integer and a radical. If the denominator of a fraction has both an integer and a radical, then multiplying the numerator and the denominator by the radical will not eliminate the radical from the fraction. So in our previous section, since we had the square root of 3 in the denominator, we would multiply the numerator and the denominator by the square root of 3, and that would get rid of this radical. But if we do that here, 1 times the square root of 3 gives us the square root of 3 in the numerator. But in the denominator, you have to distribute this to each of these terms. So the square root of 3 times 2 gives you 2 times the square root of 3. The square root of 3 times the square root of 3 gives you 3. So by multiplying the numerator and the denominator by this radical, the square root of 3, that does not help us rationalize the denominator. So that leads us to the conjugate. The conjugate of a binomial is the result of switching the sign between the two terms without changing the order of the terms. So in this example, we have 2 and radical 3, and between them we have addition or plus. We switch this to subtraction instead, and this now 2 minus the square root of 3 is the conjugate of this term. You do not change the integer or the radical, you just change the sign between them. If this term were negative, same thing. You leave the negative sign, but you change this one, the one between them, from negative to positive. So the one in front stays, the one between them changes. Now, why is this important? If a binomial is multiplied by the conjugate, then the radical sign will be removed. So this is how we're going to remove the radical sign from the denominator of a fraction. But first, let's just look at what happens when we multiply two conjugates. We're looking for the radical sign to be removed. So let's say you're multiplying negative 4 minus radical 5. Multiplying it times the conjugate, we just change the sign to positive. Negative 4 times negative 4, we're using the FOIL method, gives you 16. Negative 4 times positive radical 5 gives you negative 4 times 1, which is negative 4 radical 5. Then the inside terms, negative radical 5 times negative 4. Negative 4 times negative 1 is positive 4 as the coefficient, times radical 5. Negative 4 radical 5 and positive 4 radical 5 cancel each other out. Negative 4 plus 4 would give you 0 radical 5. 0 times radical 5 is 0. So we remove those. And then you multiply your last terms. Negative radical 5 times positive radical 5. The square root of 5 times the square root of 5 is 5. Negative 1 times positive 1 is negative 1. So we get negative 1 times 5, which is negative 5. 16 minus 5 is 11. So by multiplying this binomial times its conjugate, we wind up with a whole number. Now, before we take a look at an example, let's also discuss simplifying fractions, which we looked at briefly in the last example of our previous section. If a fraction has multiple terms in the numerator and or the denominator, then it can only be simplified if all of the terms have a common factor. So let's say you have 4 plus 8 times the square root of 5 over 6. This can be simplified because this 4, the coefficient 8, and the term in the denominator 6 can all be divided by 2. So 4 divided by 2 gives you 2. 8 divided by 2 gives you 4. And 6 divided by 2 would give you 3. So simplifying this fraction would give you 2 plus 4 radical 5 over 3. Simplifying the fraction, you are removing the common factor from the coefficient of the radical term, not the radical term itself. So that 2 comes from the coefficient. In this example, if you had 5 plus 8 radical 5 over 6, although 6 and 8 are both divisible by 2, this fraction cannot be simplified further since the 2 cannot be removed from the 5 as well. Okay, so since there's no common factor between the 5, 8, and 6, we cannot simplify it any further. Now in this example, we have 2 terms in the denominator, so we'll need to make sure that both the integers and both the coefficients are all divisible by the same number in order to simplify this fraction. And in this case, we can divide each one by 5. 5 divided by 5 is equal to 1. 10 divided by 5 is equal to 2. 15 divided by 5 is equal to 3. And 20 divided by 5 is equal to 4. So when we simplify this fraction, you get 1 plus 2 radical 5 divided by 3 minus 4 radical 6. But if you had 5 plus 10 radical 5 divided by 14 minus 20 radical 6, although these three can each be divided by 5, 14 does not have a common factor with 5, 10, and 20. So because of that, you cannot simplify this one at all. All right, so keep this in mind when you are simplifying your answers. Let's take a look at a question. Rationalize and simplify 5 divided by 2 minus the square root of 6. We have a binomial in the denominator, so we want to multiply the numerator and the denominator by the conjugate of this denominator. The conjugate, you change the sign between them. So the conjugate would be 2 plus the square root of 6. So we multiply 5 over 2 minus the square root of 6 by 2 plus the square root of 6 divided by 2 plus the square root of 6. Anything divided by itself is equal to 1. Anything times 1 is itself. So by multiplying this fraction by this fraction, you are not changing the actual value of this fraction. You are just changing how you represent it. Step 1, multiply the numerator, 5, by the conjugate of the denominator. The conjugate would be 2 plus the square root of 6. 5 times 2 gives you 10. 5 times the square root of 6 gives us 5 radical 6. And now we multiply the denominator by the conjugate of the denominator. 2 times 2 gives you 4. 2 times positive radical 6 is positive 2 radical 6. Negative radical 6 times 2 gives you negative 2 radical 6. Positive 2 and negative 2 cancel each other out. And negative radical 6 times positive radical 6 gives you negative 6. 4 minus 6 is equal to negative 2. And since this coefficient, this number, and this number do not have a common factor, we can leave the answer like this. 10 plus 5 radical 6 divided by negative 2. So that is how we go about rationalizing with the conjugate. Let's wrap things up by having you complete a few practice questions. Rationalize and simplify. Question number 1, 6 divided by the square root of 8 plus 3. Question number 2, 3 divided by 4 minus 3 times the square root of 3. And question number 3, 4 minus radical 5 divided by negative 2 plus radical 5. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. You want to rationalize 6 divided by the square root of 8 plus 3. So step 1, multiply the numerator 6 by the conjugate of the denominator. The conjugate is the result of switching this plus to a minus. So the conjugate is radical 8 minus 3. So when we multiply the numerator by radical 8 minus 3, we get 6 times radical 8, which is 6 radical 8. And we get 6 times negative 3, which is negative 18. Step 2, multiply the denominator by the conjugate of the denominator, radical 8 minus 3. When we do so, we're going to use the FOIL method since we're multiplying a binomial times a binomial. So this term is multiplied times both of these terms, and the 3 is multiplied by both of these terms as well. Radical 8 times radical 8 is equal to 8. Radical 8 times negative 3 is negative 3 radical 8. Positive 3 times radical 8 is positive 3 radical 8. Negative 3 and positive 3 radical 8 negate each other, so we can remove those. Positive 3 times negative 3 is negative 9, leaving us with 8 minus 9 in the denominator, which is equal to negative 1. This coefficient, this number, negative 18, and the number in the denominator, negative 1, can all be simplified by dividing them by negative 1. When we do so, 6 divided by negative 1 is negative 6. Negative 18 divided by negative 1 is positive 18. Negative 1 divided by negative 1 is positive 1. So anything divided by 1 is just itself. Thus, this is removed, leaving us with negative 6 radical 8 plus 18. Question number 2. You were given 3 divided by 4 minus 3 radical 3. Step 1, multiply the numerator, 3, by the conjugate of the denominator. When we switch minus to plus, the conjugate becomes 4 plus 3 radical 3. So step 1, we multiply the 3 times the conjugate. We get 3 times 4, which is 12. 3 times positive 3 is positive 9, radical 3. And now step 2, multiply the denominator by the conjugate of the denominator. When we do so, we get 4 times 4, which is 16. 4 times positive 3 is positive 12, radical 3. Negative 3 times 4 gives you negative 12, radical 3. Positive 12 radical 3 and negative 12 radical 3 negate each other, so we can remove them. And then we have negative 3 times positive 3, which is negative 9, times the square root of 3 times the square root of 3, which is 3. Negative 9 times 3 is negative 27. 16 minus 27 is negative 11. So since 12, 9, and 11 do not have a common factor, the final answer is 12 plus 9 radical 3 divided by negative 11. And then question number 3, we have a binomial in the numerator and we have a binomial in the denominator. To rationalize, we multiply the numerator and the denominator by the conjugate of the denominator. The conjugate of the denominator is the result of changing the plus sign to the negative sign. Leave the negative in front of the 2. So step 1, multiply the numerator by the conjugate of the denominator. This requires us to use the FOIL method. So we take this term and multiply it times each of these. and then we'll take this term and multiply it times each of these, and repeat that in the denominator. So first, 4 times negative 2 will give you negative 8. 4 times negative 1 gives you negative 4, radical 5. Negative 1 times negative 2 is positive 2 as your coefficient, times radical 5. Negative 4 radical 5 plus 2 radical 5 would give you negative 2 radical 5. And then negative radical 5 times negative radical 5. Negative times negative is positive. The square root of 5 times the square root of 5 is 5. Negative 8 plus 5 is negative 3. So after step 1, we have negative 3 minus 2 radical 5 in the numerator. And now the denominator, we get negative 2 times negative 2, which is positive 4. Negative 2 times negative 1 gives us positive 2 times radical 5. Positive 1 times negative 2 gives you negative 2 radical 5. Positive 2 and negative 2 negate each other. And then the square root of 5 times negative square root of 5 is equal to negative 5. So now we have 4 minus 5 in the denominator, which gives us negative 1. And we can simplify the fraction by dividing negative 3 by negative 1, negative 2 by negative 1, and negative 1 by negative 1. Negative 1 is our common factor. When we do so, negative 3 divided by negative 1 is positive 3. Negative 2 divided by negative 1 is positive 2. Negative 1 divided by negative 1 is just 1. So we can remove the denominator, leaving us with a final answer of 3 plus 2 radical 5. And that wraps up this chapter on radicals. Should you have any follow-up questions, feel free to leave them in the comments section, or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. Peace.